Welcome to Sachin Study Tech. Today topic is 8 queen problem. So 8 queen problem, 8 queens are placed in 8 by 8 chessboard. So what is the bounding function here? No two queens are in the same row and same column and diagonal. So this is the bounding function. So total number of nodes here, for example, q1 queen 1 is placed in the first row, q2 is placed in the second row, like that. In q8 is placed in the eighth row. Is row are fixed but column may vary. So how many number of nodes is there? So we can draw the state space tree. Here it is, state space tree. Here q1 may be in first column, q1 may be in second column, like here it is, q1 may be in eighth column. So we can expand this. Here the q2 may be in second column or q2 may be in third column, like here it is, q2 may be in eighth column. Like you can expand this entire tree, have the number of nodes are, so this is the formula, 1 plus summation of k equal to 0 to n and product of, so I equal to 0 to, here it is k equal to 1 to n and I equal to 0 to k minus 1, and here it is n minus I. This is the formula here. So for example, in n queen problem here, 1 plus, here it is k equal to 1, here n value is 8 queen are placed in that 8 by 8 chessboard. So the product of, here it is I equal to 0 to k minus 1, here n is the 8 minus I. So here it is, total number of nodes are 69,281 nodes. So you can expand this state space tree, solution tree, then you can get these are the number of solutions. But these number of solutions is not satisfied this constraint bounding function. Now you can discuss one simple example how we can solve this problem. Here it is. Now you can see in this 8 queen, 8 by 8 queen are placed in 8 by 8 chessboard. So for example, here q1 is placing in first column, then q2 is not placed in first column and second column. Here for example, q1 is placed here, q2 is not placed in this same column and same row and same diagonal also. So q2 is placed in third column, like that. You can expand the tree. Here q1 may be in second column, like you can expand. So but this problem is very big problem, so that's why one simple technique you have to remember. So that is 1 plus 8, here it is 9 by 2, that is equal to floor of 9 by 2, that is equal to 4. Here the q1 is placed in this fourth cell, fourth column. Here it is, q1 is placed in this row, say in this first row and fourth column. Then here no other queen is placed in this row. Okay, then no queen in the same column also, that's why I can mark this. No one is diagonally also not placed, so mark this. Now you can see q2 is, you can see the left to right, that is here q2 is not placed here, q2 is not placed here, q2 is placed here in sixth column. Now in the same row cannot place any other queen, and same column also cannot place any queen, and diagonal also can mark it, you cannot place any queen here. Then q3 is placed in this position, so you can see the q1 and q2 and q3. Okay, in the same row also cannot place other queen, and the same column also cannot place any other queen, you can mark this. In diagonal also cannot place any queen in diagonal. Now we can see q4. So there is a position for the q4 is either you can q4 is placed here or this one. So you can see the nearest boundary. So this is the nearest boundary, here it is. So q4 is placed in this here. Then in this row you cannot place any other queen. In this column also cannot place any other queen. Diagonal also can mark it. You cannot place any other queen here. Now q5 is placed either these two positions, but which is the near one, near to the boundary. Here it is a boundary, so near to boundary here it is. So q5 is placed here. Then in this same row cannot place other queen, same column also cannot place any other queen, and diagonal also cannot place any other queen. So now we can see q6 is placed either these two locations, but which is the nearest to the boundary. So here it is, this cell is nearest to the near to the boundary. That's why q6 is placed in this case, in this position q6 is placed. So in this row we cannot place any other queen. In this column also cannot place any other queen. In this diagonal also cannot place any other queen also. Now here only one position is there in this 7th row. So q7 is placed here. So you cannot place any other queen in the same row and the same columns and same diagonals also. So here 8th queen is placed in this row with 5th cell, 5th column, here it is. Only one position is there, so q8 is placed here. Now you can write the column numbers. So here it is 1, 2, 3 and 4 and 5 and 6, 7 and 8. So q1 is placed in 4th column, q2 is placed in 6th column, q3 is placed in, here it is, 8th column, q4 is placed in 2nd column, q5 is placed in 7th column, q5, and q6 is 1st column, q7 is 3rd column, q8 is 5th column, right? So you can see 4, 6, 8, 2, 7, 1, 3, 5. This is one solution. Now you can see, just you can write the in reverse order. Here it is. This is the another solution. Just you can write 5, 3, 1, 7, 5, 3, 1, 7. Here 2, 8, 6, 4, 2, 8, 6, 4. This is other solution. Here it is. q1 is placed in 5th column. Here it is. q1 is placed in 5th column. q2 is placed in 3rd column. Here you can see q2 is placed in 3rd column, and q3 is placed in 1st column. q3 is placed in 1st column, and q4 is placed in 7th column. Here it is. q4 is placed in 7th column. Like q5 is placed in 2nd column, q5 is placed in 2nd column, q5, and q6 placed in 8th column. Here it is. q6 is placed in 8th column. Like q7 is placed in 6th column. Here it is. q7, here q6 8th column, q7, here it is, and q8 is placed in 4th column. Now you can see q8 is placed in 4th column. Now you can see the same row, only one queen is there, same column and diagonal also. So this is the another solutions. So we have the more number of solutions, but it is a very big problem, so that at least you can write the 2 solutions for this problem. Thank you for watching this video. So here the time complexity is big of n factorial and space complexity is big of n. This is the time complexity, this is the space complexity. So n factorial time complexity space complexity is big of n. Thank you for watching this video.